Have you ever found yourself writing the same lines of code over and over again? Maybe it's logging a message before every important method, or perhaps it's checking user permissions at the start of several different functions. This kind of repetitive code is what we call a cross-cutting concern. It cuts across many parts of your application. It's not part of the core business logic, like calculating an order total, but it's still necessary. These concerns can clutter your code, making it harder to read and maintain. They mix what your method does with how it's managed, which isn't ideal for clean software design. This is where aspect-oriented programming, or AOP, comes to the rescue. Think of AOP as a clever way to handle these cross-cutting concerns without tangling them up in your main business logic. AOP then weaves this behavior into your application at just the right moments. The goal is to separate what your application does from the services that support it. To understand AOP, you need to know its 4 key players. First up is the aspect. An aspect is where you put your cross-cutting concern. Think of it as a module or a class that holds the code for something like logging or security. Next, we have the join point. A join point is simply a specific point during the execution of your program. Most commonly in Spring AOP, a join point is the execution of a method. When your application calls a method, that moment of execution is a join point. You can think of your application's entire runtime as a long timeline filled with thousands of these potential join points. Now, what do you do at a join point? You apply advice. Advice is the actual code that gets executed. There are different types of advice, like before, which runs before the join point, after, which runs after the join point, regardless of outcome, around, which wraps the join point, allowing you to run code before and after. But how do you tell the advice which join points to act on? You use a point cut. A point cut is an expression that selects specific join points. You don't want your logging advice to run for every single method. A point cut lets you be precise, targeting exactly the methods you care about. The point cut is the where, filtering through all possible join points to find the exact ones you care about. Let's make this concrete with a simple logging example. Imagine you have a service class called Payment Service with a method MakePayment. Your goal is to log a message every time this method is called, without adding any logging code directly inside MakePayment. The first step is to identify our cross-cutting concern, which is logging, and create an aspect to handle it. Inside our logging aspect, we need to define the advice. Let's say we want to log a message just before the payment is processed. This advice will contain a simple instruction like print, starting payment process. This piece of code is the action we want to take. It's a self-contained unit of work that knows how to log a message. Now we need to tell our before advice where to run. This is the job of the point cut. The expression might look something like, execution any method in com.example.service.paymentService. With all the pieces in place, aspect, advice, point cut, the AOP framework can now do its job. When your application code calls paymentService.makePayment, the framework intercepts this call. It checks if this join point matches our point cut expression. Since it does, it executes our before advice, printing, starting payment process to the console. We've successfully added logging behavior without touching the payment service class at all, achieving perfect separation of concerns. You might be wondering how Spring AOP actually inserts your advice code into the program's flow without physically modifying your source files. The magic behind this is a concept called proxies, when you ask Spring to manage a bean, and that bean is targeted by an aspect. Spring doesn't give you the original object back directly. Instead, it creates a proxy object that wraps your original object. This proxy looks and acts just like your original object. It has all the same methods, but with some extra capabilities. This proxy object is where the interception happens. When you call a method on the proxy, like our MakePayment method, the proxy intercepts the call. It has the opportunity to do things before or after forwarding the call to the real object. This is where your advice comes in. The proxy will first execute any before advice, then call the MakePayment method on the original target payment service object. Once that method finishes, the proxy can then execute any after advice. This proxy-based approach is powerful because it's non-invasive. Your payment service class remains completely unaware that it's being advised. This is why Spring AOP is often described as a framework for dynamic AOP. The weaving of advice into your code happens dynamically when the application is running. It's important to note that because Spring AOP uses proxies, it primarily works for public method executions on Spring-managed beans. You can't advise a private method or a call to a method within the same object because that call doesn't go through the proxy. While this might seem like a limitation, it covers the vast majority of use cases, making it a pragmatic and effective tool. So, what are the real benefits of adopting Spring AOP in your projects? The most significant advantage is a dramatic improvement in code modularity. By separating cross-cutting concerns into aspects, you keep your core business logic clean. A user service class should be about managing users, not about logging or handling database transactions. AOP helps classes adhere to the single responsibility principle: easier to understand, easier to test, easier to maintain over the long term. Another key benefit is reducing code duplication. Without AOP, you'd copy-paste security logic into each method. With AOP, write the security check once. Use a point cut to apply it everywhere. Update one place if requirements change. This makes your code dry, far less error-prone. Spring AOP is useful in many real-world scenarios. Caching is a perfect example. Use an around advice to check the cache. If the result is cached, return it without executing the method. Transaction management is another classic use case. Springs at Transactional uses AOP behind the scenes to start database transactions, commit, and roll back. Ultimately, learning Spring AOP will make you a more effective developer. It provides an elegant solution to a common problem. Centralizing supporting services makes your entire architecture more robust, more flexible, more maintainable. You can add or modify cross-cutting behaviors with minimal impact. This leads to faster development cycles and a cleaner code base that's a pleasure to work with. For any serious Spring developer, AOP is a fundamental tool for building professional-grade applications.